Push to talk. We're going to start in 1 minute.
By the way, while we're trying to solve this problem, let me remind you that you need to use the queue. So it would be great if we can enforce this fairness using the queue for the questions. Thank you.
Sorry, you're very quiet, Maria.
Okay, should I try again? All right. So my second attempt to remind you that we have a queue, and it will be great if you can use it for your questions. Most of the people do, but it would be great if everyone does, that we don't have unfairness, at least in terms of questions.
All right, so let's get started. Our first talk in this session will be evaluating the benefits, quantifying the effects of TCP options, QUIC, and CDNs on throughput. The speaker is Simon Bauer.
Okay, can you hear me well? No. Okay. Yes. Nice. So better? This way? Yes. Better now. Okay. Hi, everyone. Thanks for the kind introduction. My name is Simon Bauer. I'm a research associate at the Technical University of Munich, in particular at the chair for network architectures and services led by Professor Georg Kahle. Together with my colleagues, I conducted active internet measurements in order to assess certain impacts on performance by client and server configurations, considering TCP option usage, QUIC, and also the hosting of a web service in the infrastructure of a content delivery network. Okay. Well, why are we interested in such kind of measurements? I guess we can all agree that understanding and assessing performance of network connections as well as networks as a total is crucial. This applies from a provider perspective, where we are interested in providing optimal performance to our users, as well as from a research perspective to assess the effectiveness of arising or already widely deployed measures. So the research question we pursue in our paper Okay, so the research question we pursue in our paper is, which impact have TCP options, QUIC, and CDN hosting on the performance of internet connections, in particular on throughput? Next slide, please. Okay, before we dive into our measurement approach and some measurement results, let me briefly summarize some related work regarding the measures we consider in our study. So we consider TCP window scaling, selective acknowledgements, and explicit congestion notifications, which are around for quite a while. Yes. Next slide, please. Yeah, next slide, please. Well, in the early 2000s, researchers only found little deployment of some of the options. However, in 2013, Mirja Kühlewind et al. Found that selective acknowledgements as well as window scaling is supported by nearly 90% of domains in the Alexa top 1 million list. 6 years later, it was reported that also ECN is now supported by the majority of Alexa top 1 million domains. Next slide, please. Regarding CDNs, I guess we are well aware of their importance for today's internet. In 2021, there was a study showing that hypergiant CDNs are maintaining more than thousands of autonomous systems, while the infrastructure is continuously growing. Further, also, I guess you're well aware, in 2021, QUIC was finally specified, and in 2022, it was already observed that QUIC accounts for 8% of global internet traffic. Next slide, please. So how to assess performance impacts by these measures? Well, in order to conduct active internet measurements, we first have to identify measurement targets. So next slide, please. Okay, so first of all, we have to identify measurement targets for our active internet measurements. So we call this step crawling. During crawling, we recursively follow links from the index page of public web servers, and we are looking for files satisfying a certain file size. In our study, we decided to rely on a minimum file size of 1 megabyte. Next. Based on successfully crawled domains and according files, we then map the IP addresses to autonomous systems, which are then mapped to an organization maintaining the autonomous systems based on AS2org+. And we do that to be able to check afterwards whether a domain is hosted in the infrastructure of a CDN. We now have a list of files that can be downloaded from public web servers, and we do that, so we iterate over our target files and conduct sequences of downloads while we consider different permutations of TCP option usage, starting from a baseline that does not support any TCP option at all, then only a single option is supported, and finally, all 3 considered TCP options are enabled. Afterwards, we conduct downloads with different quick implementations. So far, our pipeline includes Quiche and IOQuick. For our study, we consider 3 different vantage points: 1 physical vantage point located in our campus data center in Munich, and 2 virtual machines hosted by DigitalOcean here in San Francisco, and 1 in Singapore. Download traffic gets captured, and we then extract different packet features and calculate performance indicators. However, we mainly focus on throughput in our study so far. So this was our measurement approach as we applied it for our first measurement series. However, we observed that the baseline configuration, which always was the first download in the sequence per domain, was significantly biased due to on-the-edge caching by different CDNs. So we repeated all measurements, including a warm-up run before the baseline, to ensure that files are already cached and all downloads are conducted with the same conditions. So this presentation includes results conducted with such a warm-up run. Okay, regarding our targets, first we generated a target set for TCP-based downloads. Accordingly, we crawled the top 100,000 entries of the Alexa top 1 million list based on successfully crawled domains. We choose 200 domains per considered hypergiant CDNs, namely Akamai, Amazon, Cloudflare, Microsoft, and Google. And then we choose 1,000 domains that are maintained or hosted in other autonomous systems. What you see in the table are successfully conducted downloads from 1 measurement run conducted in July 2023. As we only find little shares of quick support in such target set, we generated a second target set based on Google Chrome's user experience data set. Here we consider the top 100,000 entries. We scanned such domain with QScanner to identify domains that support quick, and afterwards we crawled them for files and also checked that all domains support all TCP options. However, this procedure resulted in a bit more than 500 domains that we refer to as the quick target set in the following. So measurement results now presented rely on 3 measurement runs per 1 domain. So first of all, we were interested how the usage of different TCP options impacts performance. What you see here is the cumulative distribution function for the vantage point in Munich and in San Francisco. Note that we find similar patterns between the vantage point in San Francisco and Singapore, so I will only focus on San Francisco here in this presentation. Well, the CDF shows the mean throughput observed And first, we run our warm-up download. And what we can see is that the vantage point in San Francisco shows a significantly long-tail distribution compared to the vantage point in Munich. This can be traced back to some or domains hosted by Akamai, Cloudflare, and partly Amazon that show a very, very little round trip time. So likely, yeah, the point of presence of such CDNs are quite near to our point or to our vantage points. Next, we run our baseline configuration. Note that the warm-up run and the baseline run do not support any TCP option. However, you see that the distribution of mean throughput indicates larger throughputs observed for the baseline configuration, which indicates impact by edge caching. Next, we run download supporting only selective acknowledgements, respectively ECN, and we only find little improvement of mean throughput, which can also be explained as we only observe little retransmission rates during the baseline downloads. Next, we conduct downloads with window scaling being enabled. And as you see in the distribution, this leads to a significant right shift of mean throughput in the CDF, implying significantly increased throughput rates. Lastly, we conduct download supporting all options, but only observe little increase compared to the configuration only supporting window scaling. However, analyzing distributions of mean throughput does not answer the question how significant a speed up by a certain option actually was. So what we did per measurement run is comparing the throughput of a configuration under test to the baseline throughput and accounted the runs accordingly to buckets of speedups. So first we have a look on impact by selective acknowledgements and ECN. Well, as already observed on the previous slide, such options only have little impact on the throughput of our measurements. And we also observe only small shares of samples that show a significant speedup. In contrast, enabling window scaling leads to a positive speedup for over 90% of our samples. And we observed that nearly 40% of samples supporting window scaling doubles throughput compared to the baseline, and that over 60% of samples show a speedup larger than 50%. With the same approach, we surveyed the performance of quick-based downloads in comparison to TCP. First, we compared downloads conducted with Quiche to downloads conducted with IOQuick, and we found that Quiche outperforms IOQuick in 70% of our samples. At the same time, we observed that over 45% of Quiche downloads show a double throughput compared to IOQuick. Next, we compare the TCP downloads supporting all options to downloads conducted with IOQuick, and we observed that TCP with all options results in better throughput in over 55% of our measurements. However, we observed that over 30% of samples indicate that IOQuick shows a double throughput compared to TCP with all options. If we now compare Quiche-based downloads to TCP all, we find a speedup for over 70% of samples, and that throughput is doubled for over 40% of downloads conducted with Quiche. And this already brings me to the conclusion of this talk. So what did we observe during our measurements? First of all, TCP window scaling is crucial. We did not observe such significant impact by selective acknowledgements and ECN. However, as our vantage points are kind of close to the core of the internet, these conditions might not be comparable to a user, to user conditions. Further, we observed significant differences between downloads conducted with Quiche and IOQuick. We also observed such differences in testbed measurements. Further, Quiche mostly exceeds TCP with all options. However, as I mentioned before, we conducted a first measurement series, and then we did not observe such a significant increase by Quiche compared to TCP with all options. So this motivates to run further measurements with higher iteration counts to survey the reasoning of the observed differences. Further, we observed different impacts by vantage point location and edge caching, which we further discuss in our paper. For future work, we consider to include further quick implementations to our pipeline, as well as considering further transport layer parameters. We want to integrate root cause analysis to identify throughput limitations of the downloads conducted, and as already mentioned, running long-term measurements with higher iteration counts. Further, note that we published the implemented pipeline as free and open source on GitHub, and there you also find the updated measurement results presented here in the talk. So thank you very much for paying attention.
Please join the queue for questions. Colin first. Sorry.
Hi, sorry, I'm hiding at the back, so it takes me a while to get here. Colin Perkins. So this is really nice work. I am not surprised that you are seeing the differences, although it's, especially with the quick implementations, although it's interesting that you do. I guess the question is why? Are they implementing different variants, different sets of features, or is it just bugs in one or the other?
So there are certain differences. For instance, I guess IOQuick and Quiche rely on different max data values, which is comparable to, or not comparable, but handles the flow control. This might be a reason. I'm not so deep in the comparison we did in the test bed. So what was surveyed by my colleagues there is high-speed measurements up to 10 gigabit. Maybe they could provide you more details for that question. Yeah, but as already mentioned, this were our first measurements, and in the future we will consider further parameters to better understand the dynamics of such patterns.
Yeah. Okay, cool. I think that's really nice. It would be really good to. I think I guess my long-term concern is that if we end up sort of doing these measurements, we end up with a race to see who can make the fastest version of Quick, rather than who can make the most correct version of Quick. And I don't know how to avoid that, but I think it's interesting that you're doing these measurements, and we should think carefully about what they mean.
Yeah. As I already mentioned, we are currently working on our root cause analysis approach for also Quick traffic based on Q logs. So maybe this adds additional values to these observations. Yeah, thanks for the feedback.
Hi, Simon, Dave Blanca. Way back on, I think it was like maybe your slide 18, I see it as table 1 in the paper. I see there's a huge swing between which of the hypergiant CDNs you're on versus TCP and Quick.
Which slide, sorry?
I'm sorry, slide 18. It was the one where you showed Akamai, Amazon, Cloudflare, Google, Microsoft. But what we see between TCP and Quick is tons of stuff moved from onto Cloudflare, if I'm reading it right. Maybe it's figure 1 in your paper. It's the one that says the three different.
Okay.
The three different
yeah, sorry, I have the figure in the backup slides. Just let me have a look.
Oh, you did show it. Anyway, it's table 1 in the paper. But I guess to make it a question, why can we compare, as you showed, TCP to Quick when you use the same 3 observation points, but the hosting platform is completely swung from Akamai, Amazon, Google to Cloudflare?
I'm sorry. When we compare Quick to TCP, all measurements are only conducted based on the Quick target set.
Oh, okay.
Yeah.
Thanks.
So these are the same domains. Sorry, I did not make that clear. Yeah. So all Quick results which were compared to TCP are based on the same domains.
Sorry, we have to drop the last question, and let's thank our speaker again. next talk is mapping the Ukrainian refugee crisis using internet measurements. The speaker is Tal Mizrahi. Let me share the slides.
Hi, can you see me? Can you hear me?
Yes, we can see you. I'll pass the control to you. Wait, can you control the slides?
Not yet.
Tal, are you able to control the slides?
Yeah, I don't see that I have control yet, but maybe we can just try. I can tell you when to go to the next slide.
Okay, let me, if I stop sharing, could you try sharing slides from your side? Okay.
Okay. Okay.
You're good to go.
Great. So thank you. My name is Tal Mizrahi, and this paper is joint work with my colleague, Yossi Luz. Okay, so the conflict between Russia and Ukraine started.
Sorry, Tal, we couldn't hear you. Could you be closer to the microphone or speak louder?
Yeah, sure. Can you hear me now?
Still not.
Still not?
No.
I can try to switch microphone. Can you hear me or not at all?
A little, yeah. Could you say a few more again?
How about
They're
now?
adjusting microphones if you can keep talking. Can you please keep talking? We're adjusting the volume here.
Yeah.
We need you
Can
to
you
test.
hear me now?
No.
Sorry, can you hear me?
No.
Not yet. Can you hear me?
No.
Still working on it.
Still working on it.
Can you hear me?
Yeah. If we've got another local talk, maybe switch them the order around.
Another next one. Okay, so we can come back to this talk later, and
Okay.
let me Tal, please keep testing your device. Share the screen for the next one. So the next talk is not so low hanging fruit, security and privacy research opportunities for IETF protocols. Speaker is Chris Wood from Cloudflare.
All right. Hello, everyone. This talk was supposed to be at the end, would have been a bit more interesting because now it's going to be sandwiched between two very technical talks. This is not very technical, as you can probably surmise by the name. But my hope here is to sort of pitch to the audience, people who are listening in, people who may stumble upon this in the future, some interesting problems that I think are useful for this community and perhaps others outside of the community to work on that would be beneficial to the IETF. And the motivation for this talk was I get asked quite a lot from a lot of people, like, what are some interesting problems that I could work on as a young PhD researcher, or as a student who's trying to learn more about this particular problem space or this particular area. And I figured rather than just repeat myself over and over again, I would put it down in words. And this is an attempt to do so. this list of things may evolve over time, naturally, as we solve problems and as new things emerge. But that's the intent, and that's why I'm here. However, I'm not actually going to talk about the opportunities to start. I wanted to take a step back and I guess share a bit about how I think about what's like an interesting research problem in the first place. So for me, when I choose to I guess embark on a particular problem or look at a new space, I find myself motivated by trying to deliver value or add impact in some particular way. And in my experience, the way by which I typically end up delivering value is by following an idea through a series of steps to actually getting it out there in the world, shipping software effectively. And in my experience, there's basically three, I guess, high-level pieces or components that fold into the process of shipping software. There's the core science that underlies all the stuff that we do here in the IETF and the community at large. There's the specifications that take that science and really describe how to implement it, how to actually write code to do this particular thing. And then there's the software that goes about and implements that particular specification and does the thing. So not surprising, I guess, to maybe most people here if they're engineers, but if you're a researcher, maybe this is new. I don't know. So as a specific example, consider all of the work that went into what is now TLS 1.3 and Quick. There is, if you open up Google Scholar and you search for TLS 1.3 or Quick or whatever your favorite search term is for transport security or encrypted key exchange or whatever, you're going to get a huge list of papers. I've listed some of the impactful ones here that really influence the current state of TLS 1.3 and Quick as it's specified and implemented and shipped today. But there's effectively a huge body of work. What the IETF did was build upon that work by writing these RFCs in a very meticulous way to say, this is what Quick is going to do. This is how Quick sends bytes from client to server, and this is how the transport protocol works, and this is how it uses TLS and all that stuff to encrypt those bytes. And we even have a nice, cute logo for it, which is really great. And then a huge army of people in the Quick working group went ahead and implemented a ton of different interoperable implementations. This is just a slice of the interoperable implementations that exist today. And now basically Quick is a household name. It's going to be in textbooks, and if it's not already, students are going to learn about it. Basically the future of the internet is going to be built upon this new transport protocol, which is pretty fantastic, I think. We're seeing in time, or over time, we're seeing the adoption of this particular protocol go up. There is perhaps not the most obvious trend, but the green line is kind of going up and to the right, and it was further down to the left earlier on. So I would expect as more browsers and as more operating systems enable HTTP3 and Quick, we'll see this green line go up. We'll see old versions of HTTP go down, in particular HTTP2. That would be fantastic. But at the end of the day, those, all that work that went into the core science and all that work in this community that went into the spec and all the time and passion poured in the implementations led to this value, which I consider to be pretty great. But Quick is not unique. There's a ton of different communities in the IETF that have followed the same exact pattern for delivering value and impacting positively the internet. TLS, which predated Quick, obviously did this, and I think in some ways sort of was the first working group to really kind of I guess trailblaze this close working relationship between the academic and scientific community and the actual specification that shipped out of that particular working group with TLS 1.3. We also have ACME, sort of the protocol that is behind Let's Encrypt and all of the basically which got us HTTPS everywhere, which is fantastic. MLS, which is just a recently minted RFC for doing group basically end-to-end encryption between groups, and MASC, which that's our new logo, which is pretty fantastic. Mask is like this. You can think of it like Tor for built on Quick. But I guess the takeaway is that this is like I guess a working model for a lot of the different communities in the IETF, and it seems to be something that is quite effective. And specifications are really at the heart of everything we do here at the IETF. They are the thing that allows us to take what is actually, in science and transfer it to practice. Like, we want to like take really cool things that really smart people think about. We want to be able to like ship them and use them, and specifications are the way we get there. And we spend a lot of time in the IETF trying to write like clear descriptions of these specifications so that it's easy to implement correctly and well, that we can like reasonably implement, that we can verify, analyze, and stuff like that. But I think another hallmark is that these specifications encourage like open, like, collaboration, and they really build communities around like particular problem domains or what have you. And that's important to this process, moving something from theory to practice. Software at the IETF, obviously pretty important given that our motto is rough consensus and running code. We try to the best of our abilities to like actually implement the things that we specify and get them out there into the world, because that's why we're here. We're trying to like deliver value by like, actually running this software on end users' devices, or, somehow maybe not directly on their devices, but like actually running it in a way that affects and improves someone's life. As a result of like shipping this software, we like learn new things. Maybe we learn that, oh, doing this particular thing in this way was hard. Maybe we need a new protocol or an extension to solve this challenging problem that emerged from deployment. That like feeds back into, the process of like specifying something new, or maybe like, uncovers like a new research problem that people haven't thought about before. So there's this sort of like feedback loop between shipping software, specifying things, and actually like coming up with novel ideas for stuff. And then science, while not technically like the core component of the IETF, I would argue it's at the bedrock of everything that we build upon. Without all the work that's poured into the scientific community, we wouldn't be able to like specify things. We wouldn't be able to ship cool things that solve interesting problems. Yeah, I mean, all the work that's poured into science, like it has an effect on other parts of the process. So like, someone comes up with a new idea that perhaps leads to a new specification, that perhaps leads to an implementation, that perhaps leads to another new idea that someone comes up with, that perhaps leads to a different specification, and so on. And so there's this like this feedback loop is very important for solving problems. I guess what I'm trying to say is that if you're thinking about, I guess an interesting or trying to like, engage in the IETF from a research capacity, each of these components is perfectly fine to engage in from a research capacity. You could be just a computer scientist doing science in the IETF and just spend all your time in that particular component. That would be great. You could also be like a research scientist who like really spends their time, cracking or like writing like super formally verified software that is like proven correct, and you're looking at implementation protocols that we specify. That would also be super valuable for the IETF. Or you could be someone who's like trying to like improve the ways upon which we specify protocols. All of these are useful. There is no like, I guess, preferred or ideal like way in which researchers engage. That's my like meta, I guess, part of the talk. And now I'm gonna like drill a bit deep down into, I guess, or a little bit deeper down into something that is a particularly interesting research opportunity in this space, and that is multi-party computation. So for those of you that don't know, multi-party computation is, I guess it can be really reduced to basically a way of like computing functions over private inputs. So you want to compute some arbitrary function, you don't want to learn the inputs, you just want to learn the output. That's what MPC is kind of good for. And you can imagine that there's a lot of different applications where that might be useful. the IETF is working on one of those particular applications that is privacy-preserving measurement. There's also like work above the IETF where this particular technique is useful, like using MPC as a way of measuring ad-click attribution. Recently, the IETF has embarked upon trying to standardize this type of technology. In the PPM working group, there is the distributed aggregation protocol, which is a specialized form of MPC built upon some really cool cryptography that's being specified in the CFRG called a verifiable distributed aggregation function, not protocol. This work is really exciting. It's kind of the IETF's first attempt to do something concrete in this space. It's a significant increase in scope compared to what the IETF typically does, which is client server, two-party stuff. And so this, I would argue, is perhaps like the hottest research area for people, especially security and privacy people, to engage upon, because there are some really hard problems that we need to solve, and they cover all three of the different components. For example, in the science realm, for this particular space, there's a problem called like private heavy hitters. How do you compute or solve the heavy hitter problem, which is like effectively learning what are the most common elements in some input set amongst a set of clients, in a way that's such that you don't learn the individual inputs. There are some proposals for solving this problem, but they're not, let's say, they're not as performant as we might like, or they're more expensive to run than other types of specialized MPC protocols. So it is, in my opinion, still sort of an open problem to like solve this problem in a much more performant way, and also in a way that's a bit more like ergonomic for applications. Like some of the existing solutions right now are sort of rigid in how they can be used in terms of like parameter space and like technical details that I will lose people on talking about, but are not relevant. This is a very important problem in practice, and this is something that like interested people should definitely dig into. And there's also, I guess, sort of an orthogonal problem, which is how do we like take all the work that was been poured into differential privacy and compose it with this MPC stuff that we're standardizing in a way that can be implemented safely and correctly, and that can be used in a way that's meaningful for end users. Because I guess like most emerging privacy enhancing technologies, it's not like a binary thing where you like turn on privacy or turn off privacy. There's a knob you tune, and differential privacy in particular, that knob turns out to be very important with respect to how much privacy you get and what the impact on the application is. So anyways, there's a lot of space or a lot of work that could potentially be done here on the composition of these two particular domains. On the specification side, as I alluded to earlier, there are these two emerging specifications in the PPM working group for addressing the PPM problem. That is the distributed aggregation protocol and the underlying VDAF specification. There's been a ton of work that's been poured into the underlying crypto protocol to sort of give us a reusable abstraction that we know has like very specific properties that we can sort of plug things into, and things should just work. But up above at the DApp layer, we're not really sure that the thing is correct as specified, which if you're like looking at deploying DApp in practice may be important to your particular use case. And so we need people to sort of like really dig into that specification and ask, is this thing specified? Is it correct? Does it drive the underlying VDAF abstraction in a way that is required for VDAF to be secure? For the, I guess, mechanically or the symbolic, proof people in the room, people who like Tamarin and ProVerif and stuff, I would challenge them to think about maybe we could like model DApp in one of these particular modeling languages to check whether or not it does indeed satisfies our notion of correctness or our notion of security or privacy. That's work that could be done in the specifications. And then on the software side, there's definitely a lot to do. There are, at least two, to my knowledge, implementations of this open specification. One that's developed by RSIG, one that's developed by Cloudflare. It would be fantastic if you could take these implementations or components of them or subsets of them and produce formally verified implementations, things that we know are correct, that are safe to run in production, and that don't regress any of the performance properties. It would also be fantastic if people who are thinking about like the differential privacy composition, how to safely use these things in practice, could provide guidance or like safe defaults or like API models that are just easy to use out of the box for these implementations, such that users can't shoot themselves in the foot. There are probably lots of other opportunities to be done in the MPC space. That's just a few. There are a ton of like other more qualified people in this room who may have ideas about what are interesting things to work on. And I would be happy to dispatch you to these people if you're interested. But outside of the MPC space, there's other security and privacy things that are also useful to the IETF. This topic of anonymous credentials has come up time and time again. The IETF is working on a technology called Privacy Pass, which is I wouldn't call it an anonymous credential because it's very, very simple compared to what it does. But there have been like, suggestions that maybe Privacy Pass should be extended in a particular way, or maybe it should do some other stuff that it doesn't currently do. And we're sort of like getting closer and closer to like actually, specifying and implementing and shipping an anonymous credential. And as part of, doing that, there's some interesting research problems to address. For example, how do you build these things that are post-quantum secure? We currently don't really know how to do that. In contrast to like all the key exchange protocols that we have shipped today between clients and servers. Post-quantum security for Privacy Pass and related things is kind of an open question still. There is again the formal verification question of these implementations, and then really thinking about how you could take these these constructions that exist in academia and actually specify them in a way that makes them more amenable to deployment. Because there's huge literature, a space of literature on anonymous credentials, but very few have actually made them into practice. And there's probably a reason as to why this gap exists. Bridging that gap is definitely work that people in this community could do. And then I guess a bit more lower level, you may have heard of the term as zero knowledge proof or zero knowledge proof system. This is, I don't know if it's like came out of the blockchain zeitgeist or whatever, but this is I guess a generally useful tool that's, it does have some, it actually is being used today for a number of IETF things. So for example, Privacy Pass in some sense does use zero knowledge proofs. The PPM work does use zero knowledge proofs. But there's other proposals for using these things in a way that, there have been other suggestions that, gee whiz, if we had a way to prove this particular thing in zero knowledge, we could solve this problem. But we don't yet have a reusable abstraction for such a thing that we can point to in terms of a specification and implementation that we could ship today. And working on that and trying to provide that to the community could be really useful. As a concrete example, you could, in theory, build a post-quantum version of Privacy Pass using zero knowledge proofs, and there's been some research to do that, but it's hard to specify. It's hard to deploy because these reusable abstractions don't exist. So, anyways, if I can leave you with nothing else, I would just encourage people who are thinking about research to not constrain themselves in any particular way. The research can be done all over the place. It can be done if you're a person who just cares about science and writing papers and publishing papers, cool, do the science, write the papers, publish the papers. If you care about improving specifications, come help us do that. If you care about software, that's also helpful as well. If you have questions about any of the topics that are discussed that I mentioned here that you may have already forgotten, talk to me. I will happily dispatch you to the other people who know a lot more about these things than I do, because that's the goal here is to effectively get more people thinking about these problems. So with that, I will take any questions or comments you have, if you have any. Thanks.
In the interest of time, let's just take one quick question. And there's no one in the queue, so please feel free to go to the mic.
Hi, Colin Perkins. Not a question, but a thank you for raising this. The number of times I have heard people say some variant of, why should I try to come to IETF if I do networking research? TCP is the same as it's always been. There's so many things that need research input. It's good to see them starting to be so widely enumerated. So thank you.
For sure, yeah.
Thanks, Chris.
Hi.
Sorry. Let's go back to Tal Mizrahi from Technion, and let's see if it works this time.
Yeah, can you hear me? Can you see me?
Yes, much better.
Okay, great. I'm going to try to share the slides.
It's not showing up. Yeah, could you try sharing again?
Yes.
All right, you're good to go.
Okay. So my name is Tal Mizrahi, and this paper is joint work with Yossi Luz. And in February 2022, the conflict between Russia and Ukraine started. It also started a very large wave of refugees. And if we look at statistics published by the UN, the UNHCR is the United Nations Refugee Agency. We can see here that shortly after the war started, they started publishing on a daily basis information about refugees crossing the border to the neighboring countries around Ukraine. So we can see here that on the first few weeks of the war, millions of people crossed the border. And actually, in addition to people crossing the border, over 25% of the population were internally displaced within Ukraine. So one question that comes to mind is, why is it important to know where the refugees are staying, where they're crossing the border to? And the answer is to be able to help them. And that's important for large organizations like the UN, like the Red Cross. And one of the challenges here is that it's not necessarily easy to know accurately how many people are staying in each country, especially within the EU, where border crossing is not necessarily monitored. The borders between EU countries are not necessarily monitored in terms of people crossing the border. So some of the numbers of refugees in each country are not necessarily accurate. So the goal of this work was basically to try to map the location of Ukrainian refugees based on internet measurements. So what we did was use publicly available data from various sources, data about internet usage, internet performance, in order to map where refugees are staying. So based on some of the data published by the UN, we can see here the rate of refugees per day who cross the border to some of the neighboring countries around Ukraine. And we can see that especially on the first 3 weeks of the war, there was a very large wave of refugees. If we take this graph, and basically we see the same graph on the left here, and next to it in the middle, we see the rate of Google Maps traffic in the same period of time. And we can see that there is a very high correlation between these two graphs. And actually, that's not surprising because we know that people had to move around a lot, they had to travel, And obviously they needed to use navigation apps. So that's one thing we can see, which is correlated to the refugee wave. What we can see on the right-hand side is a figure showing the ratio between mobile device traffic volume and desktop device traffic volume. So basically, we can get a general feeling of the volume of mobile device usage, and we can see that during this short period of time, there was a significant increase in mobile device usage. And again, not very surprising given the fact that people had to move around a lot. Now, another aspect we looked at was mobile device vendor usage in Ukraine. So on the left side, we see different mobile device vendors over the last decade. And for example, we can see that Nokia usage basically declined over this decade. But specifically, if we zoom in on 2022, and that's what we see on the right side, we can see that the usage of Nokia devices went up from 1% to around 13% in that short period of time at the beginning of the war. And this can be explained by basically the fact that people needed more mobile devices. They took out their old unused Nokia devices and started using them again. So that's another trend that we can see, which is highly correlated with the refugee wave. Now, one thing that, going back to the previous slide, one thing to notice here in these graphs is that the most popular mobile device vendor in Ukraine is Xiaomi. So if we look at the mobile device usage in Poland, that's what we see on the left here. We see that in the first few weeks of the war, there was a very steep increase in the usage of Xiaomi phones. And again, it's very tightly coupled to the exact same time where we saw the very large number of refugees crossing the border. And on the right side, if we look again at the mobile to desktop ratio, and we can see that in Poland, during the same period of time, the mobile device usage basically increased by a factor of 2 or something like that. So mobile devices were used a lot in Poland. So why are we talking about Poland? Basically, more refugees crossed the border to Poland than to any other country around Ukraine. So, and this is significantly more people than any other neighboring countries. Basically, what we see here is much more severe and much more distinct in Poland. So if we look at other aspects that we saw in Poland, we see on the right side here, basically the traffic volume in general increased during the first few weeks of the conflict. And also on the left side, we already saw this graph a minute ago, mobile device usage. We can see there was a very steep increase, and then it became basically constant from that period on. And this points to the fact that basically people continued to cross the border to Poland, but from there they continued to other countries. And this again goes back to the fact that people continue to other countries, and this is not necessarily monitored in any way. So basically what we saw here is the traces of the refugee crisis in Poland, as we can see them in internet measurements. One question that comes to mind here is whether the same traces could be seen in other countries as well. And when we started looking at the same metrics in other countries, what we saw was that these metrics were more affected by different factors than by the refugee crisis. So for example, if we look at the mobile to desktop ratio in Europe in general, we can see the line here is the middle of January, and in the middle of January, most of the COVID restrictions started being removed in Europe. And basically people started traveling, being more mobile, and we can see that there was a large increase in the mobile device usage. And this was more dominant than any of the effects we saw of the refugee crisis throughout Europe. So one of the conclusions we got from this is that we had to look at other metrics in order to try to analyze the refugee crisis. So more details about that in a couple of minutes. But just for a second, let's zoom out and try to understand what we're doing here. Because basically on the left side, we see how the UN data, which is published basically the number of refugees in each country, and it's based on data collected from governments, which, like we said, is not necessarily very accurate. Also data collected from humanitarian organizations. But what we're trying to do, and this is the right side, the pink side, we're trying to have an evaluation of the number of people in each country, which can be kind of a way to complement the picture. And one of the important things for us was to base this analysis on publicly available data so that we don't compromise the privacy, any privacy issues. And that was something that was very important for us. So this is what the current work tries to do. So generally speaking, like we said, February 22, the refugee crisis started. We published some of our preliminary findings in May 22 on arXiv. And as far as we know at that time, this was the only, at the time, it was the only estimate of the number of refugees in each country other than the countries surrounding Ukraine. A few weeks after that, the UN started publishing more results about generally the number of refugees in each country in Europe, specifically in Europe. And again, as far as we know, at the present time, there's no other source of data other than our work about the number of refugees staying in other countries beyond Europe. Okay, so the data we used in our analysis was basically from three sources of data. And essentially what we tried to do was use website analytics, specifically the website visit locations of each website. So we can see at the bottom an example. We can see the 5 of the most popular Ukrainian websites. And for example, on the right side, we see google.com.ua, which is the Ukrainian version of the Google search engine. So we can see that when this was captured, about 5% of the visits to this site were from Germany, about 2% were from France, and so on. This is data which is published, for example, by Cloudflare. So what we did was, first of all, we extracted the 15 most popular Ukrainian websites. And for each of these websites, we extracted the percentage of accesses from each country. And we did a maximum likelihood estimation based on that data of the number of Ukrainian people staying in each country. And each website had a different weight based on its popularity. So what we can see at the bottom here are the estimation results showing the percentage of people in each country. So for example, we can see for Germany, about 2% of the total Ukrainian population was in Germany when this was captured, which was in July 22. And about 2% of the population was in Poland. So that's the estimation results. But the main problem here is that it estimates the presence of Ukrainians in each country, but it doesn't take into account the fact that even before the war, millions of Ukrainian people were staying in countries around the world. So that's a major factor. So in order to consider that, what we did was to use historical data, and we used historical data from Wikimedia about the number of accesses from each country to the Ukrainian version of Wikipedia. And based on this historical data, we corrected the maximum likelihood estimator, which is basically a combination of data about website visits plus the historical data. And we also had a second estimator, which is based only on data from Wikimedia. So 2 estimators. And at the bottom here, we can see basically the estimated number of refugees in each country. The blue represents the data published by the UN. And the orange and gray are the 2 estimators we used here. So one major question is, how do we know whether our estimators are accurate or not? We said that the UN data is not very accurate to begin with. So in order to try to assess the accuracy of our estimators, our ground truth analysis was based on data we isolated from the UN data. And so we specifically focused on countries which are either not part of the EU or they're not accessible from Ukraine by ground transportation, which means that in either of these cases, the border crossing would be monitored. So we expect the numbers to be more accurate. So what we can see here are the numbers for these specific countries. And we can see that in the ground truth analysis, the ML estimator we had a mean percentage error of 11.8%, which is actually lower than we expected, considering the simplicity of this method. And again, it's important to emphasize that this method is not meant to replace the data published by the UN, but only to be a complementary piece here. So to conclude, what we basically did here was, first of all, try to analyze how the refugee crisis affects internet measurements, basically internet performance, internet usage, but we also tried to use internet measurements to try to map the Ukrainian refugees and to be able to potentially use that data to help and to protect these refugees. So hopefully this method can be something that is helpful in this refugee crisis as well as potentially in the future. Thank you.
Any questions?
Yeah, John Levine. I'm just wondering how you identified the mobile users as physically where they work. And I'm just thinking, I know when I roam with my mobile phone, it shows up as being in the country where the SIM is from, rather than the country where I'm physically located. So, like if I have a British SIM and I'm in Germany, it looks like I'm in the UK. So I'm wondering, you know, are you assuming that people bought local SIMs because it was cheaper, or do you have some other way of locating them?
Yeah, so what you're saying is one of the aspects that would probably affect the accuracy here is whether the location of the visits is accurate. Basically, it's based on geolocation and does not necessarily reflect what we were expecting. And I agree that's a potential factor which may affect the accuracy of this estimation. And basically, there's a whole list of factors which may reduce the accuracy, and this was described in the paper. And yes, I agree that's an issue.
Hi, this is Eve Schuler, and I have 3 grandparents who are ostensibly from that region of the world, so it's very interesting for me to see this information. Thank you. And I am wondering, you listed the percentages or estimations of percentages of refugees fleeing to different neighboring countries, and you had, of course, a very large arrow for Poland. I wonder if you were also able to reveal to us those, well, you actually didn't give it as percentages of the population. You gave it in terms of hard numbers. And so I'm curious about the percentages for those countries, because what, the impact ostensibly is that it would be harder for countries if the percentage of their population is higher for refugees. And so that's one thing. I'd love to see those numbers. It would be an interesting reveal. And I don't know if it, anyway, it would be great to see that number. And then how did you take this data? Do you have some partners who are trying to affect change from a policy standpoint in terms of where the UN or other agencies, Red Cross, things that are global, international, where their aid is going as a consequence of your numbers? So are you somehow linked into that part of the process? And that was really why I was asking about what those numbers represent in terms of percentages.
Yeah, so regarding the first question, and we basically showed the numbers as hard numbers, but the maximum likelihood estimation actually computes the percentage of people out of the total Ukrainian population. So since we know the total Ukrainian population, we can we can compute the hard number in each country.
Oh no, I was saying, what does that number represent in terms of the destination country, in terms of the populations there, so that you might push more aid to those countries where, if it's half of you've just grown the population, but you've doubled it or something like that.
Right.
You might want to put more aid in that direction. So that was the percentage that could be interesting to see.
Right. Yeah. And regarding the second question, we used publicly available data, so we were not connected to any of these organizations or companies that published the data. But we are open to any cooperation with organizations who would like our help to try to get more accurate estimates of this kind of analysis. And we would be happy to help with that.
Thank you.
We'll take one more question from Victor.
Have you taken into account, or can you measure the fact that a big fraction of the refugees have Russian actually as their primary language? Ukraine has 2 languages, and in regions most affected by the war, in fact, might be predominantly Russian.
Right. Yeah, that's a good point, and it's discussed in the paper. And there, like you said, there's a large number of Russian speakers in Ukraine, and actually a lot of the Ukrainian websites have 2 languages, so you can pick whether you want to access it in Ukrainian or in Russian. And obviously we know that since some of these sites are Russian-speaking, maybe people from Russia may be using them as well. So these are factors that we took into consideration. We tried to eliminate some of these websites which were in both languages, and also obviously there's a larger difficulty to try to assess the number of refugees who are Russian speakers, because they don't really fall into this computation. So that again is an issue which affects the accuracy of these estimates, and it's discussed in the paper.
Thank you so much, Tal. Now we're changing gears a little bit, and we're moving to our panel discussion. So panelists, please join me. All right, so it's my pleasure to welcome you to this pivotal panel discussion. Today we have the unique opportunity to take a peek into the future of the internet. Concretely, we have this unique opportunity to have 3 world-class internet experts with us who will be sharing their insights, their predictions, their hopes on how the internet would be in the next 20 years. So I will start with Jörg Ott, who is a seasonal veteran in the IETF community, celebrating his 30th year at the IETF. So join me in celebrating 30 years in the IETF. So other than a veteran in the IETF, Jörg is also a professor at the TU Munich, bringing his rich expertise in network architecture, transport protocols, and mobile network systems. He got his PhD at TU Berlin. Next, let me reintroduce Chris Wood, long time no see, who is a research lead at Cloudflare Research and holds a PhD from UC Irvine. Before Cloudflare, Chris worked on transport security. He also worked in privacy and cryptography engineering at Apple, as well as Xerox PARC. And last but certainly not least, Lixia Zhang, who received her PhD from MIT and began her career also at Xerox Palo Alto Research Center. Now she's, of course, part of the UCLA Computer Science Department, and she has been innovating with NDN, or Name Data Networking Project. So, as we all understand, our panelists will have extreme insights, and that will be an amazing discussion. But as you have noticed, the actual title is "What do we want? What do we want from the internet to look like in 20 years?" This is another way of saying you have to participate. That means that we're really welcoming and your opinions, your questions, your insights, your advice, anything, your hopes. That would be super important to us. All right? So without further ado, I just want to start the discussion. I will start from Lixia, and I will ask, what do we want the internet to look like in 20 years?
Okay, I'll be the first one. So being professor for many years, I learned one trick. I have to give lots of talks. The easiest thing to prepare a talk is to copy from others. This morning, we had a great keynote by Professor Philip Levis, if I pronounce the name correctly. I remember his last slides have the title to say that computers in 10 years, they will look very different. So we ask what we wish to happen in 20 years. That's even twice as long. How we answer that question? Fortunately, I got another quote. I look up Professor Levis' website, and this one quote I really like. He said, well, he quoted others saying that solving a problem simply means representing it so as to make the solution transparent. Therefore, I think what we wish to see in 20 years, it's really about what the problems we see today that we wish they will be completely solved, hopefully before 20 years. Did I already use up my 2 minutes slot? I will stop there.
What about your 3-minute slot?
Oh, wow. Lisha gave a great start here. I would have, following on the problem solving part, I was actually wondering, ideally in 20 years from now, the internet would have vanished, right? We don't want to see it anymore. So following up on your transparency point here, so it would be kind of ubiquitous and you wouldn't worry about it anymore, right? Nowadays, people argue about download bandwidth and whatever. If this something becomes a true commodity infrastructure,
you don't ask how many liters of water come per minute out of your water tap. You just expect it to work. You expect, well, nowadays you don't quite expect power to work, but that would be some reasonable definition of stuff being ubiquitous, accessible, maybe reasonably uncensored, if you want to factor that in, whatever that means, and globally inclusive. And well, in order not to make this too long, maybe sustainable or green. So, but maybe we can come back to that point later. If we want to make things happen at a global scale, then we probably want to have things workable everywhere, which also means efficient and low energy.
So Chris, do you want to chime in?
Yeah, sure. So I think York summed it up pretty well. I think in 20 years, I'd like to stop thinking about the internet. Maybe everything is a solved problem at that point. I don't know. But actually, more seriously, it's really kind of hard to see what the horizon looks like, and 20 years is a bit further beyond the horizon, I would say. I would say that I hope the community of people who are like, doing things to help propel the internet forward, continue doing so consistent with principles that I find important. So, putting privacy, ahead of other potential, I guess, things that run counter to privacy on the internet would be something I'd like to see continue moving forward. Of course, there's like other things that Jorg mentioned, like maybe we could be a bit more energy efficient with how we do things. Yeah, sure. That's like that's always, no one's going to disagree with that, right? But I hope for a sort of a continuation of a principled approach to how we continue to do things in the IETF and I guess beyond the IETF. Which is kind of vague, but that's the best answer I can give. 20 years is a long way down the road.
Do we get another round?
Yeah, I was going to ask.
Can I have a follow-up on your initial? I was just wondering if, if a transparent internet or like one that just works and nobody really thinks about it is what we're looking for, then who would actually fix it? Whose job is it? Is it like technology that is missing? Is it policy, regulation, legislation? I don't know. Did I destroy your follow or lady?
I have my answer to your question, but let me bring up my question. So my first round, I didn't really bring up the question. Let me talk about this. There's a Winston Churchill. I hope most people can recognize the name. And he has one quote I really appreciate. It's something like, the farther backward you can see, the farther forward you're likely to understand, equivalent to that degree. You can Google that. So this reminded me a conversation I had with some old timers long time ago, probably in the 90s. I remember that the few people around, the two names I can remember, I don't think they're here. One is Christian Huidema, and the other one is Bob Hendon. I remembered we joked to say how many problems we actually solved after so many years. When we say so many years, we thought was already many years because the IETF started in 1986. That was in the late 90s. We recalled in day one, we had 3 problems. We worried about the 3 problems, I should say this way. Routing scalability, network congestion, security. By that time, we looked around to say that the routing problems, scalability, we always say the network routing scalability was a problem. Even I think in the early 2000-ish, there's even a routing research group. I was one of the co-chairs. But despite this persistent problem, it has never stopped or even slowed down the internet growth. So eventually I realized that's not a roadblocker. Now about congestion control, there's a similar thing, right? We still have congestion control research group, I think, right? And there's working groups as well. But fundamentally, since Van Jacobson invented this TCP slow start congestion control problem, I think we have that problem under control. People continuously improve the performance, resiliency, whatever, all kind of criteria I did applied to that problem. But by and large, internet is no longer like having this congestion collapse that literally happened during the late 80s. You know, I was on the network. Don't think about you could do anything during the day. It just entirely stopped. At the time of the graduate students, we had to work at the night, so you could do FTP. That's no more, long gone. But think about the third question, security. Even back in the late 90s, we realized we had not made lots of progress on that problem. And even today, I would claim, personal opinion, of course, this is the #1 problem, #1 challenge facing the internet today. And what's missing is not a lack of effort, but rather a shared understanding of the problem space and, of course, the solution space. I heard the mentioning about privacy. You know, I'm a kind of this is the outrageous opinion speaker. So I would say that the privacy is not a standing alone problem. It's part of the security. Without a security system, there's nothing to talk about privacy. So I will stop there.
So we have a couple of questions, people waiting in the queue. Maybe Christopher Patton. Yeah.
Hi. Yeah, this is a great conversation to have right now, I think. I wanted, it's kind of follows up on what Professor Zhang was talking about. I wanted, well, taking a step back, we want the internet to be invisible, but I wonder, and the analogy you used was like plumbing, the way plumbing is invisible, maybe the internet could be invisible too. I wonder if that's possible. The internet is not just, it's not just like, it doesn't serve a single purpose. The purpose is always changing. It's very much influenced about how we use it. There's an attacker in the network that's, you know, we're envisioning underpinning all of this communication. So I wonder if you think, if anyone thinks that's actually possible, or if we could rule that out.
You can always wish for things, right? The question was what we would wish the internet to be like in 20 years. And I suppose, I mean, take everything that, every piece of infrastructure that you need to do, it needs maintenance, right? And right now, given the amount of effort that we spend every day on fixing little things like access, so networks being down, access lines being down, mobile internet not working everywhere, and all these kinds of things, that is a step way before we even get to attackers and applications. So I think if we would get that part of invisibility solved, we would be a long way, because then we might actually find enough time to focus on the other problems. So that would be one response to that, or one thought.
You know, panelists need to argue with each other, but actually I agree with Jörg on that. That is, it's not so much it's disappeared entirely, nobody takes care of that. Instead, of course, plumbers are always needed. The question is what is the frontline challenges? I don't think that should be the low-level connectivity. Yeah. We have long passed that stage. Again, back then, 30, 40 years back, the connectivity was a hard problem. These days, the problem is at a much higher level that deserves attention.
Yeah, I guess I would generally agree. I think the use cases and applications that are driving how we think about the internet and how we use it are going to constantly change. The threat models are going to constantly change as things in society change. and the internet will have to, like, aspects of the internet will have to change to adapt to that. And there's probably some analogy to be made by to the plumbing thing. Like the way you think about plumbing might change as a result of like how stuff works. Don't know. But yeah, I don't think it's ever going to go away. I think the interesting task for us will be to ensure that as the internet continues to evolve, that it continues to evolve in a way that is, as I was kind of saying earlier, I guess generally good, and doesn't like fall off the rails or implode or whatever, right?
An important point to add to this is this doesn't mean that networking research becomes unimportant.
I mean, of course, yeah. Like,
just in case funding agencies hear that.
Well,
Thank you.
It
Thank
depends
you.
on which level of networking, right? I'm co-chairing the decentralization of the internet research group. We just published the workshop report for a workshop 2 years back. I think the attention these days is not about so much the network as if connecting things together. The attention and the conflict is really moved to higher level. Think about who has the most power controlling the internet. People tend to say ISPs, old days. Today, no, there's somebody else way above the interconnect level.
So Abhishek, can you, okay. While you're going to the mic, Alexia, can you kind of elaborate on like, what do you mean by decentralization authority? Can you elaborate on that a little bit?
Sure, given that I'm the DNRG co-chair, that's our business. These days, centralization or otherwise decentralization is a very kind of important topic. Lots of people pay attention, if not everybody. But I think that we need to have first agree on the definition. People say the cloud services is a centralization. But on the other hand, there's this thing called economy of scale. I don't know about other people. I used to do backup myself all the time. No more, right? Upload to the clouds. That's economical because it's economy of scale. The cloud storage can do the backup for, I don't know, millions of people or billions of people. Cloud is necessary. So therefore, decentralization doesn't mean we don't need the cloud, but rather I think fundamentally is who is in control. Today, I can tell you why I feel that I lost control just with one simple example. Who am I? I'm a nobody, except that Google gave me an identity called the Gmail address. That's how I am kind of recognized as a netizen. I go anywhere on the web, it's the Gmail, it's the Google. It says this is the person, and Google will do this authentication when you visit other sites. That is what I call losing control. And I prepared a few slides. I don't know if Maria, you could show that. You cannot, because like I said,
like 6 questions, people like
Okay,
lining up.
I'll
So
stop
since
there.
we really encourage to have
Sure,
people
sure.
discussing. Sorry, Abhishek, I interrupted you last
Yeah,
time.
my name is Abhishek. I'm from Meta. I'm going to present a little bit of a contrary view to what the panel has been saying, and maybe it takes the discussion to a different direction. I don't think internet will be a commodity in 20 years. And here's why I say this. There will always be very interesting problems. Here's why I say this. Current world population is about 7.5 to 8 billion. Only 3.7 billion of that population is connected right now to the internet. When I say internet, I mean the entire, till the user device accesses it, the entirety of it. World population in 20 years, we don't know, 16, 17 billion, connectivity challenges removed, Some of them are technical challenges, some of them are economic challenges. Let's assume that removed. Experiences become more interactive and more immersive. So which means a lot more data than, I mean, there's already 90% of the traffic on the internet is video. We're talking about more immersive data, faster latency, more interactiveness, getting bandwidth delivered as well as with the latency constraints. And then on top of that, let's put the supply side. Wireless spectrum will always be limited. You can't generate, there's some physics-based boundaries that we have that we can't, unless a Nobel Prize worthy of research happened and we figure new ways of sending information. So that part is limited. And then you have all this influx of more people connected on the internet, more interactive and immersive applications which demand much better latencies and bandwidth. So I don't think we'll get to, I don't know, this is my opinion, we're not going to get to that plumbing, just plumbers fix it. There will be hard problems to solve. Again, just
but I don't think this is a disagreement, right? The fact that if you grow an electricity grid, if you grow if you grow a road network, if you grow whatever, you need to overcome new engineering challenges. And I don't think anybody of us is arguing that we are going to have demanding challenges ahead of us that we need to face. But still, a pretty nice perspective would be to get over having to fiddle with the basics on the side of the user, not necessarily on the side of the ISPs or whoever that might be in the future, right? So I don't think there's a disagreement between what you say and what we have been saying.
I would give you a counter argument. This is a quote I wanted to say. This is an attribute to Jeff Houston. He had a blog several years back. He said that it's truly amazing that the sum of human knowledge is at my fingertips. It's also truly frightening that all this information is only accessible through a single company. That is centralization. This single company controls, by measurement, over 90% of the search market. And even you look into the infrastructure, the connectivity, there's a great infrastructure consolidation. I think there's a good talk given by Craig Leveridge, I forget how to pronounce his name, at some recent NANOG. They did a study, I remember clearly, back in like 2010 SIGCOMM, showing the measurement of the global backbone. By that time, there's so-called tier 1 ISPs that interconnect big chunk of the internet. Today, I think his latest measurement showed like close to 90% of the traffic is carried by CDNs and private networks. That really shows where those tier 1s, how well they are doing now. The public internet backbone, as far as the traffic volume is concerned, is disappearing faster than you can imagine.
Just to quickly respond. Yeah, absolutely no disagreement with you. As things get bigger, we're going to have to solve new engineering problems. And as I was saying earlier, like the answer can't be, oh, to deal with the scale, we have to turn off encryption or whatever. That is like absolutely the wrong thing to do. And so we're going to have some tough times ahead to like enable a continuation of the services we have, but then also, support new things like this interactive like stuff. I don't know, like VR, AR, whatever the new fancy stuff is. And it'll be quite hard. Looking forward to working on that with you.
Let me invite Wes, who is
right here.
Okay, great.
Wes Herdiker, USC ISI and the ICANN board, but speaking only for myself. To answer your question of like, where do I want to be in 20 years? I can tell you the things I can't do now. My wife is somewhere else on the planet. I can't figure out where she is without like going through some centralized service, right? We have to share not only where our location is, but our relationship and everything else. Many things have gotten in the way of that. And I think in part, a lot of it has come with the advent of mobile devices, right? My wife often carries 2 devices at least that I might be able to communicate with her through. So my question is, how in 20 years can I get to the place where I want to be that allows me to do things like have secured communications, you know, in a decentralized way? I'll give you one other, my other famous thing to do is like if I want to print something, I want to say, hey, print something to Chris's printer, right? Chris is a very context localized sensitive name, and it's only because I'm staring at Chris, you know, could anybody actually figure out that I'm talking about that Chris, right? And his printer. That's how humans work. That is not how we have the internet working today. So my fundamental question is, how do we get to an end-to-end private communication situation in a dynamic and mobile environment with secured identification, location discovery that is all decentralized? Good luck.
Like one problem at a time, I would say. Doing end-to-end encryption first would be like fantastic. I think we're on our way there, but those are absolutely hard problems to solve. And I believe we've talked about them before in the past. Wasn't there some like workshop where on naming stuff? I don't remember exactly what, but yeah, yes. That does seem like a very admirable goal to get to. Not clear to me if the trajectory we're on will like head in that direction, given the forces of centralization at play. But I would like to see us get there.
So, Wes, I really want to answer your question. So you want to communicate with your wife directly with the end-to-end security. The fundamental thing, the very first question is, how is your wife identifiable? Like I said, I'm just my Gmail address. So therefore, you don't have a provider independent identifier. How dare you to talk about end-to-end encryption? Today we have lots of encryption work, HTTPS, okay? It's a really secure communication. But there are 2 questions I can raise with regarding to that security. The first of all, there are guys who actually decrypt your data. It's not the server. Who are those guys? Middle boxes, CDNs. And these days, there's also DDoS mitigators. Okay, when DDoS happens, the servers have to deploy the same mitigation at the service. You can buy that. They have to decrypt your traffic, all the traffic, to sort out good from bad traffic. So this so-called end-to-end encryption doesn't really exist in the generally speaking manner. The second thing is that it's not end-to-end like you communicate with your wife. You actually talk to the server, guys, because you are not an independent entity. You have identity on the internet. And until we solve this problem, there's no true end-to-end as user end to user end, period.
So in the end, what you wish for is actually privacy-preserving, globally scalable, decentralized rendezvous, right? And that's what we would need to be working for, which has a few problems on the way that probably feasible, but small ones.
Just to reply to that, I don't think anyone in this room is going to disagree that centralization is happening and that there's like very few parties that maintain like a significant market share of like traffic and data and whatnot. So I think we can all just assume that that's a matter of fact, and we maybe would not like it to be that way. But as I guess a more technical response to what you're saying, Lisha, you're saying that like we don't really have end-to-end encryption in practice, which is really surprising to me because there are like a number of systems that actually deploy this technology today, and they do have a very well-defined concept of what an identity is. So like WhatsApp, for example, like ships today end-to-end encryption for messaging, and they identify users by their public keys, and they have a system for ensuring that those public keys are consistently and correctly bound to like an individual and a user. So there are things we can point to that say we know how to do this in practice, and for end-to-end encryption in particular, which is a separate topic from centralization. We should keep those like very different or very separate if we can. But I just wanted to like correct that.
I just want to ask Wes, do you recognize your wife with her public key?
But that's exactly the point of these systems like WhatsApp's like key transparency system. Like you don't have to think about like what is Wes's public key, what's my friend's public key. Like the system takes care of that binding for you. Like we have the technology to sort of do that. And in fact, there's like a new working group that's likely going to be formed to like standardize that technology to and give us that binding that we need, where you can associate a given public key with an identifier like an email address, a name, phone number, whatever. Like we're well on our way to shipping this stuff. Yeah.
I think, Christian, you and I have a much longer conversation, but beyond this panel. So I will not waste your time here.
Yeah. YA.
Hi, I'm Waj Vartat. I'm joining from Montreal, and I'm a quick security PhD researcher. And I have a question that what are the potential implications of quantum computing on internet security over the next 20 years? And how might quantum affects the targets and impact the internet infrastructure? Thank you.
Can you repeat? I'm not sure any of us got that.
I got that.
Okay, what are the potential implications of quantum computing on internet security over the next 20 years? And how might quantum attacks target and impact the, internet infrastructure?
I didn't quite get the second piece, but I think I got the first piece. And to echo it back, it was like, what are the implications of quantum computing on like the internet for the future 20 years? And it's like not great for stuff that we're deploying today with classical cryptography. And thankfully, we are well on our way to deploying post-quantum cryptography in a lot of cases. Like for right now, for example, Chrome is shipping post-quantum encryption for TLS, and it does talk to some servers. So we're making headwinds and strides to like get ahead of that particular curve. There are other types of technologies that we're shipping today that we don't have easy drop-in replacements for, but it's ongoing research and development to like develop post-quantum solutions for those particular problems. And I'm confident that people who again are like much smarter than me can figure them out, and we can talk about them in the IETF and get them standardized and get them shipped. So I know there's just like this this looming threat of like post-quantum attackers, but I am very confident in the community's abilities to deliver and like, deal with it in a timely manner.
I agree. So any new problems, I think we'll solve it. That's not the challenge. The challenge is really understand what are the problems.
Interesting. So we have the first optimistic agreement. Yes. Don?
Hi, John Todd from Quad 9. So I think in order to understand the most optimistic future, it's also interesting to understand more of the pessimistic parts of the future. We're looking at kind of a future where it is possible actually to have perfectly encrypted and secure communication between endpoints. And I think there's technical problems that we have to overcome, but we'll get over that. There are, however, very strong political oppositions to that for a number of different reasons: security, national government, this push towards data sovereignty. So I'd like to get the panel's opinions on what you would see. How far do you see the pendulum swinging back towards kind of a negative view of things before it swings forward again? Because I think we're in a good optimistic position right now with these technologies making things possible. I think that in the next 5 to 10 years, we're going to see some pushback on that, and some of it may be quite severe. How far are we going to go into that direction before we come back out of it?
Just to clarify quickly, by like the negative direction, you mean like catering to the request to like backdoor or client-side scan or whatever like that. Great. I can take it. Yeah. So I guess no surprise that I believe that we should continue on this path of like encrypting all the things and ensuring that like the systems that we build, we can reason about their security properties in a way that makes sense. And the proposals that I've seen for I guess doing client-side filtering for CSAM purposes, for example, they don't technically make any sense in any reasonable threat model. So I'm not so worried about that, like kind of bringing us back. I guess what I am worried about is sort of our inability to come up with an actually technical solution to this problem, for which I do not know of one that exists. I think that's like the hard problem here. Like how do you build an open system built on open standards and open protocols in a way that can't be like easily subverted by like changes to the endpoints, or can't be abused by like service providers to like compromise end user privacy and confidentiality? Don't know. Super hard problem. A lot of smart people thought about it. Unclear how much longer we can kind of stay on the path of trying to encrypt all the things before we acknowledge that we can't solve this problem and it has to come back. But I hope it doesn't go in that direction. That's probably the best answer I can give. But thank you for bringing your pessimistic view.
So we sometimes agree, other times we have to disagree. I think that that's what I said, part of what I said earlier, that for the security, we really need to reach a shared understanding of what other problems. Like currently, it seems to be some kind of conflicting. That is, there's end-to-end encryption, there's some other forces trying to countermeasure that. So I'll just give an analogy. You know, this is the US. We should have individual freedom. That individual freedom is not protected by everyone carries a gun. That individual freedom is guaranteed or enforced by the law. And therefore, we should all understand that the technical solutions do not solve societal problems. We need to understand that. So therefore, it's not so much of thinking about fighting the government, but rather we need to make laws that will govern everyone's behavior, including government. That's my personal opinion.
Yeah. Agree.
Well, somewhat agree, I guess. I find it difficult to say that we will be able to reach a shared understanding of the problem when the problem is can be defined in many different ways and interpreted in many different ways. Like, for example, how do I in the end-to-end encryption and client-side scanning particular use case, I may consider, you know, the fact that I can like send private information to someone else like a feature, and then someone else considers that a bug because I'm like sending CSAM or whatever. I do not have hope for us like establishing any sort of consensus on what the problem is. I am very confident we can agree on like what the technical facts of the situation are, but coming to like a shared you know, this is the problem that that everyone needs to solve at the same time. I do not see that happening.
Well, you have this fundamental problem that you would like to have the good, strong security protection, whatever, for yourself, but not necessarily for the potentially evil others. And since everybody disagrees of who oneself is and who the others are, that's an unsolvable problem to begin with. And you can either engineer for these properties to hold or for them not to hold, but that will always affect everybody. So that we don't get out of.
Well, I would say that from different perspectives, there's always a conflict. I mentioned about individual freedom. Yes, we all have freedom, but under the constraints. That is, your behavior do not harm others. So therefore, we are living in a society. We have to have principles how to resolve those conflicts. So therefore, that requires a law, requires consensus. It's not that people hold different views, or different parties, I should say, hold different views, and we say we cannot have a shared understanding. We have to.
Tobias.
Tobias Siewich, Max Planck Institute for Informatics, speaking for my...
Can you move closer to the mic, please?
Tobias Vivek, Max Planck Institute for Informatics, speaking for myself and not for my affiliation. So we had some comments about taking positive and negative views of the future. I would argue that there are very positive views of the future taking at the moment. If we look at our world, we are facing a world that is heating up. We are facing societies collapsing. We are facing water running out. We are facing wars around water, around land, around resources, tearing apart our world, currently tearing apart Europe already. And in that world, I'm not sure whether plumbing of the internet might be a relevant thing to consider. Putting it to plumbing, while plumbing might still be there in 20 years, the water running in those plumbs might not be a commodity anymore. So I would like to hear the perspective of the panel on how the internet will look in such a torn apart world.
Well, that's actually a good problem. No, there's obviously a big picture that may be beyond our scope here. There's one thing when it comes to I mean, fundamentally, this is there's multiple things you can say about this. One bit is that if the internet has enabled one thing in the past, then it would be sharing of useful information, besides all kinds of disinformation, which might help assist coping with future problems. But of course, the internet itself creates resource consumption. And we had this example earlier that was given saying that we are going to have higher bandwidth demands, lower latency, yada, yada, yada. In the past, we have been pretty good at coping with internet scale by throwing more technology, more energy, more whatever at it, in order to sustain our growth, to enable growth, enable things getting faster. In the light of your very question, that might not be very sustainable in the long run. So we might need to reconsider how we are going to organize future growth to embrace the next whatever billion people it might be, and or whoever might be left, or whatever you want to say. But so merely just adding more routers, more fibers, more processing power is not going to be not necessarily going to be a long-term sustainable approach here. So that might be one aspect of that.
I agree with Jörg that this is a really big problem, and perhaps beyond the scope of this particular panel. And your kind of question was like, what does the internet look like in this, sort of future society? My pessimistic view right now is that there may not be like a singular internet. We may end up seeing like effectively the things be fractured and fragmented. We're kind of already seeing that in a way in terms of like what information is available where. But as like the infrastructure that surrounds like the internet and shapes the societies that use it, I only kind of see that fragmenting getting worse. I would like to be proven wrong, but like, that seems to be like the kind of trend we're going down. But
so can you explain what so-called fractured really means?
So there's certain places in the world. No. Like there's certain places in the world where like I can access certain information and I can't access other information. That is.
That's already the fact today.
That's what I'm saying. I've already, yeah, that's what I said.
But when we talk about 20 years down the road,
yeah, it might get worse.
My point is that it will likely get worse.
I'm more optimistic. I agree with Jörg that I think in terms of getting the remaining part of the world all interconnected, it's not purely a question of fiber. Definitely fiber will be needed, more fiber will be laid. We have been increasing the fiber layout, I think, very fast. But at the same time, we really need to look into new ways of communicate. The wireless, the peer-to-peer. In the academia, you see so many publications with regarding to data mills. I reviewed papers that your phone can be data mill connecting the disconnected parts of the world. I think that area, I hope, will become reality in less than 20 years. The question is, why can't we do it today? I always say that if we fully understand the problem, not what I said, I quoted Professor Levy's quote, right? If you can explain the problem so clear enough, the solution will offer itself. So we really need to go down the level. Why can't we do it? This data mule model of communication, this peer-to-peer communication. People say, oh, we have peer-to-peer, look at the BitTorrent. Everyone should know BitTorrent, how it works. It depends on centralized servers.
I started writing people like letters in the mail. That's how I communicate with them if I want to get in touch with them. And that was kind of a joke.
And we'll take one more question from hopefully Sivan.
Yeah. Hey, Shivan Sahib, Brave Browser. Just wanted to respond to something I think you were saying, Lisha, where you said that like privacy is just a subset of security. I guess I disagree. The classical response to that is that you can have a very secure connection between your browser and a web server somewhere where it's fully encrypted and all that, but the user or you have not consented to this information transfers, which I would think is a privacy violation, but totally is secure and fulfills all our definitions of security. So yeah, I guess this disagreement over there. But I think why it's important to keep this in mind is because like privacy plays really well into like decentralization or like like how do you distribute keys, and like all of that conversation becomes interesting if you're thinking about like classically privacy, like a privacy lens where you're thinking about like transparency and trust and consent. So I think that's why it's important to, like in my opinion, like keep in mind that privacy is like its own thing, which is you need security for it, but it's also like independent of that.
I think you actually agree with me, now disagree with me. I said that the biggest problem, as I see today, is the shared understanding of the security problem space. I don't see TLS encryption as so-called security. No, TLS is a tool, not the security itself. We need to understand what is security in the first place. And therefore, until then, you cannot say you disagree with me. Privacy is not part of security.
Okay, maybe I think I should join that conversation you're going to have with Chris later on.
All right, and with that, like a full circle of what Pixia said in the beginning and now, let's thank our panelists. It was an amazing discussion, and everyone. And also thanks everyone for their very insightful opinions and questions that were super helpful in having this nice discussion. And sorry, Dan, Eric, and Juan and Eduardo for not taking your questions.